Hey, today we're going to continue talking about hypothesis tests, and now we're going to switch a little bit over to doing hypothesis tests for means, much like we did when we talked about confidence intervals. So a lot of the same structure as a hypothesis test for proportions or two proportions, a lot of the same structure as confidence intervals for means. Um, some minor tweaks. So of course, when we write our hypotheses, this time we are going to be reporting hypotheses about means. Remember that we use the Greek letter mu for a population mean. And that's what we're trying to see um, if it makes sense that this is our population mean. And then we have our null hypothesis mean, that's the claim that we have made. And our alternative, again, is always going to be a inequality. And this is the way we calculate our critical value, and this is how we calculate our standard error. And these types of things are also on the formula sheet. So of course we always start justifying that we're allowed to do this process. We need to do our assumptions and conditions. I'm going to keep saying it's very important. I probably won't write them out in this lesson because we need to focus on the new portion of that, but this is something that we have been talking about since we started confidence intervals, and we'll continue talking about through our hypothesis tests. We must satisfy assumptions and conditions. We must always have a random sample or a randomized experiment. We must always have independence between the individuals in our sample. And if we know those things are not independent, we need to make sure that we've sampled less than 10% of the population. And then we need to check a normal condition. So when we have proportions, we're checking some NP and NQ to see if they're greater than or equal to 10. When we're talking about means, there is no P or Q because those are proportions and that's not what we have. We're going to go ahead and check the distribution of the sample to see if it's approximately normal. We don't want it to be skewed. The larger our sample, the bigger the skew we can handle. The smaller our sample, the less skew we can handle. And of course, we're looking for something around 30, but we can deal if we have something smaller, but it's not really skewed. So go ahead and take a minute to read this problem about gas prices. So let's talk about assumptions and conditions. We're trying to see if this data from 10 gas stations in this state show evidence that the average price of gas is different than what they're reporting it is. And so we do have a random sample. So these were selected at random, these 10 gas stations. 10 gas stations is certainly less than 10% of all the gas stations in a state. So even if these prices were not somehow not independent of each other, they're less than 10. They're less than 10% of all the gas stations in this woman's state. So we can say that these prices are independent of each other. And then we need to check to see if a normal model is appropriate. This is kind of a small sample size, n is 10. And so we should definitely go ahead on the calculator and put this data into a list, which I've already done. And we're going to want to go ahead and look at the plot of that. So I have this already in there. I'm always going to zoom 9. And I wouldn't say that this is skewed. I wouldn't necessarily say this is looking like a normal curve, but it's certainly not skewed. You might say it's slightly symmetric. I think we're going to be okay to use this data. The data points are packed in pretty tight. There's no gaps. So we'll go ahead and proceed. Proceed maybe with caution. So we satisfied our conditions. Let's write a set of hypotheses. We're talking about means, average. That tells you we're talking about means. So we're going to use the Greek letter mu. And then what she read was that the average gas price is $3.06, so that's what we're going to assume it is, unless we can prove otherwise. And we want to know if it is different. So that's an indication that we should use a not equals to inequality for our alternative hypothesis. So we're going to run a one sample, because we have one sample, t-test. We should always say what kind of test we're doing. If we're not going to calculate these things by hand, then we should say what test we're running on the calculator. We have one sample. We're talking about means, so it's a t, and we're doing a test. We're not doing an interval. So let's go ahead and calculate a p-value. We could also say this is a two-sided test, so we're doing 2 times the probability that our sample mean is greater than, and then of course we'll get a sample mean when we do this calculation. So I'm going to do that. Stat, tests, t-test. I'm going to use the data option because I put that into the calculator. We're going to tell it what our null hypothesis mean is, which is 3.06. I put my stuff in the list 1, so tell it to grab my list 1 data. I'm going to make sure I have the correct alternative selected, the not equals to, and then I'll calculate. And so we'll get the t, the critical value, we get our p-value, we get our mean, our standard deviation, and our sample size. So I'm going to go ahead and grab my mean 3.038 just to fill this out. So this is saying, hey, look, we're finding the probability that our sample mean is greater than this sample mean that we got. And then we're doubling that probability because we also want to know the probability that it's less than that. And we get a p-value of 0.224. And of course, I should have mentioned alpha at the front. We'll say it's 0.05 because we weren't specified otherwise. And so we're going to compare those. And so we always compare the p-value to alpha. And we're going to say that our p-value is greater. So the saying goes, if the p-value is small, or this p-value is small, reject the null. Well, in this case, our p-value is larger than alpha, so we are going to fail to reject our null hypothesis. And so what this means is we're not saying that the average gas price is $3.06. We're not guaranteeing that. We're not saying it's true. But what we're saying is, based on our sample of 10 gas stations, we do not have enough evidence to say that the gas prices are different than reported. So let's write that up. So again, when we write this up, we always want to reference our p-value, what we're comparing it to, our significance level or of 0.05. We don't have enough evidence. We failed to reject a null hypothesis, so there's not enough evidence to reject a null hypothesis, and so we cannot show that the average gas price is different than reported. Usually I steal the context from the problem. It says, is there evidence to show the average price of gas is different? No, there is not. And then, of course, add in the important information. As always, you should ask questions if you need some help. You should do some practice because that's how you get used to making sure you do assumptions and conditions, choosing the correct calculator operation, interpreting your p-value, deciding whether or not to reject the null hypothesis or fail to reject the null hypothesis. All of that stuff takes practice. The more you do it, the better you'll get at it, the more sense it will make. So make sure you ask for help, make sure you do some practice, and make sure you stick around and answer the questions that I ask you about this problem, speed in construction zones. Good luck.